So that's all we got. We got the source in parallel with the resistor, in parallel with the inductor. We're looking for the instantaneous power. Power supplied by the source, taken by the resistor, and taken by the inductor at t equals 1 millisecond. Well, we know power equals voltage times current. Instantaneous. So if I know the voltage through each one, we can calculate what the power. Or if you remember, it's I squared times R. In this case, will be times Z. Using Ohm's law. Or the voltage squared divided by Z. You can use any one of them. I should be able to calculate the voltage. The voltage here we'll call V, or V sub t. They're all in parallel, must be the same voltage. So if you assign current leaving, we can do it. So first let's change that to phasor. In phasor, this is 12 angle 0. Resistor does not change, still, is it 2000 or 200? 200 ohm, that was a typo, should have been 200. Not 2000. So 200 here. And the inductor is j omega L. J omega is 2000 and L is what? 0.2. What's that? 400J? 400J. This is V, capital V, because we're in phasor now. We'll call this IR. We'll call this IL. Coming down. So KCL, all the current entering the node, if we add all the current going into the node, should equal all the current leaving that node. What is going to that node? 12 angle 0. What's leaving? This voltage minus this, which is V minus 0 over 200, plus this voltage minus this, over 400J. Remember, J in the bottom will make it a minus J on the top. That's because of the conjugate. J times V over what? 400. Because you multiply the top and the bottom by J, and J squared is negative 1. That's why if you have a plus J on the bottom, we'll make it a minus J on the top. If you have a negative J on the bottom, we'll make it a plus J on the top. Okay, let's multiply everything by what to get rid of the fraction? 400. Zero, zero, 8, 4. 4800 angle 0 equals 2V minus JV. 2 minus 1J, V equals 4800 angle 0. V equals what? Divide this by that. 4800 angle 0 divided by 2 minus 1J. And I got 2146.63. 63 is good. And the angle, I don't leave myself any room to write the angle. 26.6. got a plus.
I got a plus
26.6. So if I know what V, I know what I sub R. I sub R equals what? V divided by 200. So divide that number by 200. I sub R is 10.73 angle 26.6 degrees. And I know what I sub L is, which is what? V divided by 400J. Divided by 400J. Okay. I get 5.37. Is that what you got? 5.37 angle negative 63.4. So now we know the voltage and the current. Remember, the voltage, that's this circuit right there. Now let's go back to this. This is plus to minus. You get the current entering the plus. That means this resistor is going to do what? Absorb the power. This one is going to absorb the power. This one is going to supply the power. Why? Because that's the voltage. This current entering the minus side. So this will be a minus power is being supplied. This will be a positive power, means it's been taken, absorbed. So the question, what is the power supplied, absorbed, taken, all the stuff? So here we go. Let's look at the source. Power by the source is going to be V times I, and that'll be supplied. Well, the source, here's the source. The voltage is 12 cosine 2000 t. Oh, that's the current, I'm sorry. The voltage is what? Right here. If you change that to time domain, this will be what? V as a function of time is going to be 2146.63 cosine, what was W there? 2000 t plus 26.6 degrees. And this one is going to be what? 10.73 cosine the 2000 t plus 26.6 degrees. And this is going to be what? 5.37 cosine 2000 t minus 63.4 degrees. Here's the little problem you're going to be facing. This one in radian, that one in what? Degrees. So we need to convert all these degrees to radians. So to convert them to radians, you divide them, you multiply by pi over 180, right? So this will be 2146.63 cosine, still the 2000 t, but instead of 26.6, that's going to be pi times, where's pi here? Pi times 26.6 divided by 180 degrees. Now you're in radian, 0.464. This one is going to be 10.73 cosine 2000 t plus 0.464. And this one is going to be 5.37 cosine 2000 t minus 63.4 times pi divided by 180. 1.107. So now we converted these values from degrees to radians. So let's look at the source. What is the voltage across the source? Right here. 2146.63 cosine 2000t plus 0.464 times the current. Again, let's look at the circuit. What was the current? The current through the source is what? 12 cosine 2000t. Now, the question is, we want it at 1 millisecond. This is a function of time. At 1 millisecond, the power by the source, 1 millisecond. You put a 1 here, so what do we have? Is that a 2? 1 for t? Or 0.001, that becomes a 2. Cosine 2.464 times 12 cosine of 2. Make sure you calculate in radian mode. Mode radian. 2146.63 times the cosine of 2.464 times 12 times cosine 2 equals 8351. 8351.6.
Where'd you get the 12 cosine 2000t from?
That was your current source, Kyle.
Oh.
That was given to us. And it's supplied. So supplied, normally we write what? Minus sign, right? Minus means supplied, plus means it was taken. If you want it in kilowatt, you can round that to negative 8.35 kilowatts. The minus again indicates it was supplied. The inductor is going to be interesting, actually. You'll see why I say that. Now let's look at the resistor. What was the average power absorbed by the resistor? I'm instantaneous, yep. What's the instantaneous power absorbed by the resistor? So we do voltage times the current through the resistor. We say it's a plus because it's entering. Notice positive current entering the plus side. So the instantaneous power is a function of time taken by the resistor. It's going to be plus the voltage as a function of time times the current through the resistor as a function of time. And here's the voltage as a function of time. They all in parallel have the same voltage. 2146.63 cosine the 2000t plus 0.464. That is the voltage. And what's the current through the resistor? 10.73. 10.73 cosine 2000t plus 0.464. Now at 1 millisecond, put in 1 millisecond, 2146.63 cosine 2.464 times 10.73 cosine 2000 2.464. 2.464 twice. That's squared. Cosine 2.464. Square that number. Multiply it by 2146.63 times 10.73, and it shows up 13980. Interesting. Notice the source is supplying what? 8,000, and this one's taking what? 13,000. What's happening there? They mentioned something in the problem. Let me just read it again to you. A current source of 12 cosine 2000 T amp, a 200 ohm resistor, and a 0.2 Henry inductor are in parallel. Ready for this? Assume steady state condition exists. What does that mean? That means that inductor is fully charged. When that inductor is fully charged, it's going to react as a source. And what's going to happen now, the inductor is actually going to supply power, not absorb power. That's what's going to happen. Otherwise, you short. You're supplying, the source is supplying that much, and the resistor is taking that much. Somebody else is supplying the power.
So does the opposite happen for a capacitor?
Nope.
In parallel?
Nope.
No.
So this is 13.98 kilowatts plus. So let's see what's happening. We drew a picture like this. The math is going to tell us I'm wrong. It's going to see it's a minus. I drew my picture as what? This is plus to minus. So I'm assuming the inductor is going to what? Take the power, absorb the power. So I'm going to continue with that assumption, see if the math is going to tell me you're wrong. The inductor will supply. So I have a positive current entering the plus, so I'm assuming it's going to absorb the power. Let the math lead me. So what's the instantaneous power? I keep saying average. By the inductor. I'm saying it's a plus. That's the assumption I'm making. Voltage times the current through the inductor. And what's the voltage? Again, it's the same voltage. 2146.63 cosine 2000 T plus 0.464 times the current through the inductor, which is what? 5.37 cosine 2000 T minus 1.107. What is the instantaneous power 1 millisecond for the inductor? 2146.63 cosine 2.464 5.37 cosine, what's 2 minus that number? 2 minus 1.107. This will be 0.893. So here we go. 2146.63 times cosine 2.464 times 5.37 times cosine 0.893, and the math comes out as negative 5631.7. Negative means what? Supplied. So that source, once it's fully charged, that inductor, once you fully charge it, is going to act as a voltage source and is going to supply power to the circuit. So that's negative 5.632 kilowatts. Now if we add the two numbers here together, it should equal to the power absorbed by the resistor, or close to it. Let's add them and see, because conservation of energy. Let's add them. 8.35 plus 5.632. Is it 13.98? Is that what the resistor took? The power supplied equals the power absorbed. So that's instantaneous power. Again, what that meant, remember how inductors and capacitors react? Let me just organize this. Yep. What happens to them when they charge and discharge? This is what happens in that example. So it says, assume that inductor reached steady state. That means you pass this point. When you're rising, your voltage is changing. Once you pass that point, notice your value is what? It's almost constant. So that inductor starts to react as a source and is going to supply the power. The same thing with the capacitor. Yes?
And are we only to make that assumption for a steady state condition?
Yeah, because it said assume reach steady state. Assume it's fully charged now.
And that's what steady state is?
Yep.
Okay.
Notice this one starts to level steady.
You said it's for an inductor?
Inductor or capacitor. You know, capacitor, when they charge like this. And when they discharge both of them, they discharge like this. So after a while, notice once you reach this point, that's really steady, that's level. So after that, you go, oh, there's nothing left. But from this time, there's voltage coming or current because this one's discharging. But once you reach that, it's gone, it's empty. Yes?
You know, it's obvious that like a source will supply power, but
Yep.
I keep getting a positive number for the calculation.
For the source?
Yeah, do you just throw in a negative?
No, if you put the values in, actually. Where is it? Where is the source? Cosine 2. Oh, because you have to add that minus sign here because you're entering.
Oh, you're entering the negative.
Because you enter in the negative, right? So immediately your equation here will have to say negative, which means you're supplying the power.
Got it.
So you put that negative number, and when you do the math itself comes out positive. Is that what you're saying? Yeah, and the minus sign forces it to be negative. You can use the words supplied or observed instead of plus and minus too, you know.